Howdy y'all. Today we're going to be learning about natural language processing, feed-forward neural networks, and specifically today we are going to be learning about the neuron. So here is a diagram of a neuron. It might be a little overwhelming at first, that's okay. We'll go through it together. The main work of the neuron looks like this. We call the output of this Z, the weighted sum. Now, this weighted sum equation may look very intimidating. Let's break it down. Z is the output of this equation, which is, as we've said, the weighted sum. Z is a scalar value. B is the bias. Now you may be wondering, what is a bias? We often represent the output of a neural network with a graph like such. A bias essentially translates the graph vertically. In the case of a singular neuron, we are just adding a number to the initial scalar value. Here, we can see that there is a summation happening. I is the total number of values we are calculating in the sum. For example, if we give the neuron 24 W values and 24 X values, then I would be 24. And I am. This begs the question, though, what are W and X? W and X are vectors. You can think of a vector as an ordered list of numbers. So W sub I is the ith element of the vector. W is a vector of weights. You can think of weights as determining how important we are saying a corresponding X value is in the calculation. For example, here we are saying that the first value in X matters 0.2 amount. Now what is X? We say that X is a vector of features. But what are features? Features are any characteristic that we are observing. In the case of natural language processing, these could represent words. Note that the actual values inside X should all be scalar values, not strings. However, we can encode strings to be numbers. In essence, in the summation, we are multiplying each paired scalar value of X and W and adding them together. You might recognize this as a dot product. It's okay if you don't know what this is though. So our equation for the weighted sum becomes Z equals the dot product of W and X plus B. But wait, we are not done yet. What is going on with the rest of this diagram? We apply a nonlinear function to the weighted sum. Now you may be wondering, what is a nonlinear function? We will talk about three of the popular ones. Sigmoid takes the input and puts it into a range between 0 or 1. Tanh takes an input and produces an output between -1 and 1. ReLU, one of the most popular activation functions in natural language processing, outputs Z if Z is positive and 0 otherwise. Each one of the nonlinear functions we mentioned output the activation value for the unit, A. The output of the entire network is Y. In the case of a network with one node, as in this example, A and Y are the same. That's everything you need to know about neurons. Check out our feed-forward neural network video next. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.